Hey everybody, welcome to Bill Sky, the C and C++ guy, and today we're going to talk about inserting a node in between two nodes in a linked list. Now this isn't appending a node, which I did a video on a couple of videos back, but this is actually inserting it into the middle of a linked list. In between two nodes is the first node, so it's kind of an insert, well not kind of, it is an insert function that we're going to do. Now if you haven't watched the appending node, if you haven't watched all the other videos, please watch those videos because this video builds on those videos, and you can find links to those videos in my playlist or in the description of this video. So what we're going to do is we're going to start off with the deleting a node code, and we're going to modify it in C. Now, for those of you that are C++ programmers, this will apply. This code is almost nearly exactly the same. However, you will have to do some retrofitting to put it into C++. And the way that you can do that, if you don't have any idea what I'm talking about, go take a look at the appending nodes in C++. And what I did there was I took the C code and I retrofitted it to run under C++ or compile under C++. And that'll show you everything you need to know, and you'll be surprised at how easy it actually is to do that. So let's jump right into this coding. Okay, so let's talk about the design of this inserting in between. Now, just like the deleting a node, to insert in between two nodes, you need to have at least one node. So you can insert into the head node in the very first node or the only node, or you can insert it in between two nodes. You can't really insert at the end because that's an append, right? So you would use the append function. I mean, you could code it that way, but I've chosen not to do that in my design. So you can only insert at the beginning or in between two other nodes. So if the list is empty, if the head is equal to null, we're just going to return false. We're going to return something else. We're going to say, nope, it didn't work because you have an empty list. The next possible condition is that you have multiple nodes in the list, and what you want to do is you want to insert the node there. Now the way that you can do that is you create a new node. So we're going to create the new node right here. So first thing you do is you create a new node. You place the head's next pointer. You copy that into the new node so it points to the first node. And then you assign the head, so the head will now point to that guy and not there. So that's how you insert it. It looks kind of messy there, but that's how it actually would look. So what does that mean? It means, if I can get this window out of here, it means that it looks like this. The inserted node is there, the head is now pointing to the new node, and then the new node is now pointing to what was previously the head. So that's our first condition. The second condition is that we want to insert it in between two nodes that exist. Now to do that, the way that you would do that, get my pen going here, is that you will navigate. So you'll start at the head and you'll navigate to the node where you want to insert before. And that would be right there. So this is the node right here that we want to insert before. Now while you're doing that, you're going to be wanting to keep track of the previous node as you go through the loop. And we did that in the delete node video. And we're going to do it again here, but that's what we do. So we navigate, and we navigate to the end position. So we want to insert here. So our end position would be 1, because that's the 1 node, and this is the 0 node, okay? So let me go ahead and clear all that up. So once we know we're at that insert here position, we create a new node. We make the previous nodes next. We put that into the new node. We make the previous nodes next now point to our new node, and we're pretty much done. So that's how you do that. And you don't have to worry about the current node next because it's pointing to the next node or it's pointing to null at the end. And you always want to remember that we also have to put the data in the new node and your next pointer. We have to put that in the new node as well. So that is the second condition. And what it looks like, it ends up looking like that. Our new node is in between those two nodes. Now, another condition is that you've wanted to insert a node past the end of the node. So for instance, let's say that we want to insert before node number 5 and you only have 3 nodes in your list. Well, I'm not sure how you can insert in node number 5 when this is node 0, 1, and 2. There is node number 5. So we're trying to insert it somewhere that doesn't exist. Hyperspace maybe, maybe inside of a black hole. But well, remember, black holes, they do keep information, so we're okay there. So anyway, so you can't actually do that. So you have to write your code in such a way where if the user typed in something that was invalid location, you want to accommodate for that. Now there's also another possibility, is that if the user typed a negative number in the insert before, so you want to make sure that the negative is not there. And we had to do that in the delete node as well. And what we're going to do is we're going to take that delete node code and we're going to retrofit it for this insert before code. Okay, so let me go ahead and get this, our project here. And what we're going to do is we're going to create a new function prototype. So we're going to say we're going to return a Boolean, insert node at, and we're going to do the head, because you could insert before the head, so you have to be able to update the head. So we have to send a reference to the pointer. So we're going to say here's the value that we want to insert, and here's the node position where we want to insert. So our function is going to be a little bit different. It's going to have 3 arguments instead of just 2. All right, so let's go down to our delete node code, and I'm just going to copy that, insert node at, all right, and we've got the int the data and int the node. Now it doesn't matter which way you do these, but you need to keep track of it in your function. Okay, so I'm going to leave all this the same, and let's take a look. So our first test case will be if the node is less than 0. If they send you a node that was less than 0. And we're going to go ahead and do that. I'm going to go up here to the main, and I'm going to say insert, and this is our delete test cases, insert node at. Okay? Let's put some valid comments in there. And I'm going to go down here and comment out all of my other test code, so we can just test that one thing at a time. And this needs 2 arguments, so we're going to say -10 and the position. Well, actually, let's give it a value of 10, and the position will be -10. Again, let's make sure we've got this right. So it's integer the data and integer the node, just so we can keep track. All right? So the data and the node. So we're going to try to insert 10 at position -10. Let me see, node width value 10, inserted at position -10. Again, we're just testing out our error conditions first. All right. So this should work without any issues because we are using the same code that we used. Now let's take a look at what our errors are here. Oh, did I forget something? There we go. I put a space in the function name. All right, so let's run this. And we can see that empty node 1 not deleted. Well, actually, what have we done here? Oh, okay. So I still have these test cases here for delete. So let's get rid of that. We still have some test cases here. I didn't clean everything up like I thought I did. All right, let's take a look. All right, so we added 10, 20, 30, 40, 50. The side of the list is 5. Node with value 10 not inserted at position -10. And the reason for that is that our first test case was to return false if they typed in a number less than 0. Okay, now it says else if the head is not equal to null. And let's take a look. Else return false. That is the test case where you have an empty list and you're trying to insert in front of. Okay, so we definitely do not want to insert in front of something that doesn't exist because it's an empty list. And you can design this differently. It's however you design it. So let's go ahead and let's uncomment that from the delete. And let's go ahead and say insert node at. I'm going to say the head, we're going to insert the node 99 at position, I don't know, 0. Okay, and let's put some code in there. Empty node 99 inserted. So we're just making sure that if we have an empty list, the insert at does not work. All right, empty node 99 not inserted. So great. So our code worked. We just simply, like I said, we just cannibalized the delete node at code to make it a little bit faster for us. Again, if you don't know what we're doing here, take a look at the delete node at code video because it'll show you everything we're doing. All right. So else if the head is not equal to null, then we're going to look to see if the node is equal to 0. So if the node we want to insert in front of is equal to 0, that means it's in front of the head. So what we're going to do is, let me see. So I'm going to say temp node equals next node, so that's cool. I'm not deleting anything, so let's get rid of those current nodes and the free. Okay? And then I'm going to go ahead and create a new node. So do we have a new node pointer here? Yeah, we could do a temp node. So let me make sure that I get this code right, allocating a new node. And I'm going to get this from the append node code that I did. Okay. Okay, so we saved the current nodes. We saved the current node, which is the head. We saved the current node's next pointer because actually, is that true? No, I don't think that. Let's take a look at our design. What do we do if we're going to insert in the front? Let's take a look. Well, what we want to do is we want to create the new node, add the data to it, place the head's next pointer into the new node's next, and then assign the head to the new node. All right, so that makes sense to me. So let's go ahead and create the new node. Let's do it in the order that our design said to do it. And then what is the second thing we do? We place the head's next pointer into the new node's next. Okay. So then we say, and I don't think we need this in, so we're going to say new node dot next node equals to current node dot next node. All right. Now remember, current node is equal to the head when you first start because we did this assignment up here at the top of the code. All right. So what's the next thing we want to do? We want to assign the head to the new node. All right, great. So the head equals new node. All right, great. Let's build that. All right, now let's see if that worked. So the way that we're going to do that is we're going to go back up here to the main. And let me see. We're going to put test inserting before the first node. Okay, so we're going to say delete or insert node at, and we're going to give it a number of, let's just say 5, 0. Node 0 inserted, not inserted. And then we're going to go ahead and print off the list to make sure 5 is at the beginning. All right, let's run it. All right. Oh, guess what I did? I forgot to put the data in. So it looks like it inserted the node because we've got the 5 there and we've got the... Oh, well, that's a problem, isn't it? It looks like we've got an issue. We didn't actually insert it. It looks like we overlaid it. Oh my goodness. So let's take a look at what we've got here. So yeah, our test did not work correctly. All right, so what did we do? If the node is equal to 0, so it was equal to 0, then we say we create the new node. I forgot to put the data in there. So new node dot the data equals, and what was it was called the data. That's the value that was passed over to it. Then we say new node next node is equal to the current node next node. Well, actually, that's not true. Is that it? Place the head's next pointer. Ooh, I think that's an error. We want to place the head into the next of the new. What we're doing is we're putting the next of the head. Oh, this design is wrong. I love it when I make mistakes like that. So we don't want to do that. We actually want to put the current node. We want to put the head, because the current node is pointing to the head. We want to put the current node into the next node. And then we say the head equals to new node. Oh, we could have done it this way too. I could have just said the head. I could have done it that way too, but for some reason I decided to just say current node. All right. Let's go ahead and build that and see how that works. Ah, much better. So we've got 10, 20, 30, 40, 50. It says node 0 has been inserted, and now we have 5, 10, 20, 30, 40, 50, and now it's size 6. All right, pretty cool. Pretty cool that we got that working. We found a design flaw. I'm going to have to fix that in my design document. And I should actually do that right now so I don't forget to do it. But we're not going to do that right now. We'll go ahead and continue with the coding. All right. So what's the next test case that we want to work on? Let's take a look at our design. Again, it's not perfect, but it's going to be there. All right. So now the end node has a node before and after it. So that means it's not at the end. It's somewhere in the middle. Okay. And then we've got a number of things that we need to do here. So let's go ahead and find that test case. And actually what I can do is I don't need that test case there, the old test cases. I think I might want to do this test case, but we'll do that in a little while. Okay, so let's go ahead and do a test case. Let's move everything over a little bit. Okay. We want to test inserting between two nodes. And if you notice, what I'm doing is I'm keeping track of where I am based on, using the design. It's so important when you're doing a complete solution. Okay, so we're going to insert 35. Now, where do we want to insert it? I'm going to insert it between the 30 and the 40. So this is 0, 1, 2, 3, 4. So I want to insert it before 4. So let's put node 4 there, node 4 inserted, node 4 not inserted. Then we'll print the list, and then we'll print the size again. Now I don't believe this is going to work. Obviously not, because we're using delete code. Okay. So what we need to do is, the first thing we need to do, if we look at our design, we have to navigate to the node position specified end, saving the previous node. So, and I believe our delete code does this. So let's see. Yep, it does the previous node there. So so this is the code right here that is actually going to allocate the new node. So let's go ahead and delete all that we don't need. Okay. So I'm going to say temp node equals current. So what do we have to do? I'm going to look at the design. So once we get there, it says create the new node and add the data to the node. Okay, so here we go. So we're going to create the new node and add the data to the node. That's up here. I don't think those are correct. Okay, so we're going to create the new node and add the data to the node. What is the next thing it says? Place the previous node's next pointer into the new node's next pointer. So we're going to put the previous node's next pointer in the new node. So we're going to say new node dot next node equals previous node dot next node. Okay? Now we know we're not at the beginning. We know we're somewhere in the middle simply because this right here took care of the condition that we were at the beginning. So we're not going to be at the beginning here, so we don't have to worry about it having an invalid value or previous node being blank. Okay, so we did that. And then we're going to say place the new node's pointer into the previous node's next. Didn't we just do that? Place the previous node? No. So place the new node's pointer into the previous node's next. Okay? So we're going to say previous node dot next node equals new node. All right, pretty cool. I don't know if this is going to work, but let's take a look. Okay, and we've got a warning here that we're not using temp node. We'll get rid of that after we test it. All right, it looks like it worked. So here we go. So the size of the list is 6. Node 4 was not. Why was node 4 not inserted? Did I not return true? I certainly did. So there's something else going wrong here because it did insert it. You can see it right there, and the list is 7. So there's something wrong here. You know what would make this code a lot better is that if we created a Boolean called return value, and we made that equal to false. And instead of doing this return false, I'm going to say return value equals false. I'm going to say return value equals true. Return value equals true. And what we're going to do down here is we're just going to say return value. All right. Okay, I think, I'm not sure. So let's say, nope, return value equals. And what was that? If it's not equal to null, that's empty, so false. And then we're going to say return value. I'm not sure if this is going to fix that problem. We still might have an issue, but let's take a look. Okay, it says node 4 not inserted, when indeed it was. So let's take a look. So we say while not return value equals true, so that's going to break out of our while. We're going to ask if this is probably where we're having the problem. If node CTR1, if node CTR minus 1 is less than the node, you know something? We might need this to be node CTR. That minus 1 was from the delete. Let's see what we've got. Okay, node 4 inserted. Okay, so that fixed that problem. However, we still have to test this, which means I tried to insert past the end. So in this case, that fixed that problem. So there's our 5, 10, 20, 30, 35, and 7. Okay, I believe we have one last test case to test, and that is if we try to insert past the end. And what was really cool was in the delete node code video of that code, we didn't have to change anything. It worked. So let's say if that's the case here. So I'm going to go ahead and create that test case. And I don't really need to print here. So we're going to get rid of that. Test inserting past the end of list. And I'm just going to say 99. So I'm going to put 99 and I'm going to say 99 nodes. All right. Node 99 inserted. 99 not inserted. All right, cross your fingers. Let's see if this works. Node 99 not inserted. All right. Now, the list is 7. I want to test something a little bit different here. I want to try to insert it after position 6. Okay, that's a little bit more of of closer to the actual end. So let's see if that works. I can't insert before 7 because 7 doesn't exist. Node 7 not inserted. Pretty cool. Let's do a node 6. Let's see if we can insert in front of the last node. And in this case, I do want to print it because I want to see, in this particular test case, I want to see if it actually did insert it and the date is there. Okay, a little bit of a problem. So 0, 1, 2, 3, 4, 5. Oh, it did insert it in front. So it did so no problem. It did insert it in front of node 6 because this is node 0. This is node 1, 2, 3, 4, 5, and this was node 6 right there. So it did insert it into node 6. But if we say insert at node 7 would be down here, but there's nothing there. So we don't insert in front of it. Pretty cool. So that worked out. I think we did some really good test cases there, and I think this code is all done for inserting the node before. Alrighty, so that's the insert node at function. If you want to do this in C++, it's so simple. You just copy this code into the linked list class and as a public function or public method, object-oriented terminology, and take a look at our appending a node in a linked list in the I think it's 28B, or it might be 20, no, I think it's 28B, that video in C++, and you'll see how we retrofitted the C code into C++. Very simple. And hope to see you at our next linked list video.